This is bad news. My God.
Falling out right now.
Anything could happen. Wow.
I'll watch the video later.
Feel the heat. I need more nights. I need water.
Ain't dry mopping this.
Hi everybody, Joey Caribou Weather Dude here again, and welcome to the ongoing series Weather in the Fire Environment. Today's topic, clouds you should know, doesn't just relate to firefighters, it relates to everybody who works outside or cares about weather and things as such. With me today is my good friend Brandon Houck. He's down there in Brooks, Alberta. Weather guy who's always on the Meteorological Report show every week with Frankie and I. Hi Brandon, how's it going?
Oh, it's going great. I'm currently inside a cloud.
Nice.
In a stratus cloud.
Today, Brandon, we're talking about clouds, types, and associated weather. Formation of clouds. So this relates to the textbook for weather in the fire environment for firefighters in British Columbia. Clouds are formed by certain process with a lifted parcel of air. We note these lifting processes in the previous section on air mass instability. See my previous video on the topic. As the parcel is lifted in the air, the air in the parcel cools to the point where the moisture in the parcel condenses and forms a visible cloud. At this point, precipitation may start falling from the saturated cloud. Classification of clouds can be by the height above ground at which they form, the cloud levels being high clouds, middle clouds, low clouds, and by whether they form as cumuliform or stratiform. Cumuliform clouds normally have vertical development. They stack up. They're greater than the horizontal area in which they cover, whereas stratiform clouds have little vertical development compared to the horizontal area. Some clouds may exhibit characteristics of both forms. The type of cloud can give an indication of the atmospheric processes that are at work and therefore the weather conditions to expect in the near future. A stratiform cloud is formed by lifting stable air, and cumuliform cloud is formed by lifting unstable air. Okay, did you get all that? So what we're trying to talk about mostly here today is real practical things when we're talking about clouds. So we're going to talk about high clouds first. And these are the clouds that start at 20,000 feet and higher. And these clouds consist of ice crystals and they have no precipitation. And they have no ice crystal, they have no precipitation because it's cold up there, right? So the first cloud we're going to talk about is the cirrus cloud, Brandon. And that's a wispy thin... Seriously.
That one again?
This one. It's a wispy thin cloud, often called mare's tails. Usually fair weather is happening, but they can be indicative of approaching warm front a couple days off or a jet stream overhead. You know, I can think of times, Brandon, I've seen the mare's tails immediately ahead of a thunderstorm.
Yes. Sometimes you can get cirrus clouds, some serious clouds ahead of the more serious clouds.
Yes, they can be an indication of the jet stream overhead. And why do you think this is so?
Well, definitely make sure that that shows that there is a changing weather pattern ahead. Usually you get these types of clouds, you get those cirrus clouds way up in the upper atmospheres, and they can sometimes tell a story. And as you can see, they can tell that there is a changing weather pattern ahead, and it could be a big change in the weather pattern.
Sometimes the direction of those mare's tails and cirrus clouds also tell us about, things that are happening on multiple levels. Like you may have wind on the ground moving one direction, yet when you look up ahead, the mare's tails are moving a different direction. So maybe it could be a sign of wind shear, I suppose, right? Speaking of which is the cirrostratus clouds, and we know these ones because they often make the sun dogs and the moon dogs that they see that and they say, oh, rain is coming. So it's like a blanket of cloud with the sun. It's visible. The sun's visible, so it makes a halo around the sun. It's the first indication of an approaching warm front, forerunner of precipitation in the next 18 to 30 hours.
Usually when you get that in the middle of winter time, it's like, oh, it's finally going to warm up, because that's the indication that there might be an approaching warm front coming. And that's the same thing too, is ice crystals all across the sky there.
Another example of these ice crystals then is cirrocumulus. This is sheets or bands of small white flakes or very small globular masses. May look like ripples in the sand on the seashore. There's unstable air up there, often a forerunner of thunderstorms later in the day. Virga possible. Certainly it's an indication when I wake up first thing in the morning and I look up, it's not, the sun hasn't really burnt off things yet in the morning. It's still kind of early and you look up and you see these cirrocumulus clouds way up there above you and otherwise clear sky and you think, uh-oh.
And another really cool thing about the cirrocumulus clouds when you get these they're kind of like they're like a fish scale in the sky, kind of like what you call a bit of a mackerel sky. Whenever you see these kind of mackerel skies that are situated right over top of you that look like a fish scale, that can indicate rain in the next 24 hours.
So if you're looking higher up, there's 3 levels of clouds you're mostly looking at, right? And these are the ones that are at the highest level, the high clouds. Well, let's talk about the ones that are in the middle. And these are the ones between 6,500 feet and 20,000 feet. So they consist of water droplets, super cooled water droplets and ice crystals, light rain or showers as possible, and maybe no appreciable precipitation in the middle clouds. And the first example we'll give is the altostratus cloud. It's a grayish sheet or blanket of cloud with the sun dimly visible or invisible. No halo. The air is stable, pre-warm front with light rain or virga associated. So I think of that altostratus, as being the way that things can be for long periods of time sometimes on the coast.
Yeah, and with virga is meaning that is rain that is falling from these clouds and evaporating before they make it down to the ground. So a lot of you probably look at those virga because the virga itself, they have this this kind of sheet thing kind of look to it that kind of looks like a funnel. It's some people think they're funnel clouds, but they're not. They're virga. So I always get pictures of that stuff coming into me because I'm out here in the prairies and everybody's like, oh my gosh, is that a tornado coming? No, not a tornado. That would be virga. Rain.
Yeah, you can see virga in lots of different layers of the sky kind of too. Like I've seen at the base of a thunderstorm.
Yeah.
Virga's
a dry
happening.
Thunderstorm, yeah.
Yeah, the rain's trying to come out, but it's evaporating before it hits the ground, or convection's driving it back upwards. Let's talk about the altocumulus cloud. The altocumulus, sometimes you see these gravity waves in the altocumulus.
Yep.
Patches, bands, or sheets with a rounded or rolled shape appearance. Globular masses. There's unstable air there with very light showers or virga possible. It may be frontal. It may be pre or post frontal or associated with an upper trough. So that's kind of all over the place, isn't it?
Oh, yeah. I actually saw those clouds last week, to be honest with you. Yeah, they were altocumulus, and they were pretty much actually more so kind of street cloud-like. So you get those kind of street clouds that go across the sky, so they look like a kind of rows, I guess, of clouds of these altocumulus clouds that look really cool. So if you ever see that around, that's pretty cool to look at.
They're not a great indicator because they can be pre or post frontal. Next, we'll talk about altocumulus castellanus. Individual tower-like cells, unstable air mass. Thunderstorms often develop later in the day. Maybe frontal, pre or post frontal, associated with upper trough or unstable air mass. Light rain or shower or virga possible. Sometimes when I think of these altocumulus castellanus clouds, and same with the Flaccus clouds we'll talk about next, I see these sometimes early in the morning as well on days that prove to be very unstable days. I can think of times being out in the prairies where I woke up and saw that and thought, man, it is game on today. Especially, I can think of one day in particular out in Brandon, Manitoba, where all hell broke loose that night.
Mm-hmm. Oh, yeah. Absolutely. Definitely can tell that these types of cumulus clouds, altocumulus clouds, can definitely indicate the potential for a fairly unstable day. So there's instability there, and now we just need that trigger.
And that's the same with the altocumulus Flaccus. So we can put altocumulus clouds kind of in the same category, whether they're castellanus or Flaccus. Puffy white clouds looking like cotton balls, unstable air mass. Thunderstorms often develop later in the day. So again, these ones that I've seen in the morning sometimes, within the first couple hours after sunrise maybe. And they're often telling.
Absolutely. Yeah, definitely can. Yeah, I've definitely seen days like that right here in the prairies where you have these little puffy little cumulus clouds around, or these, those altocumulus clouds. And that usually indicates that, this is going to be a big day. Absolutely, especially for severe weather wise. And the other thing that I always feel, especially if there's an east wind, so if there's an east wind with these types of conditions around, and the atmosphere feels a lot more, as I'm going to say the word, moist, or You get a kind of a heavy, that kind of little bit of humidity in the atmosphere. So yeah, the relative humidity's up, the dew points are up, they're meeting together as well. So that can indicate that the day ahead can definitely be quite a stormy day.
Well, and it's funny you say that because that day in Brandon, Manitoba, I believe it was July 2016, that exact same thing happened. When I got up and looked at the flags there at the exhibition grounds where the Brandon Folk Festival was to take place, all the clouds were or all the flags on all the different masts at the stadium there were blowing out of the east, facing towards the west. And I saw all the altocumulus clouds, and I just knew it was going to be awesome. And it was. There was tornadoes that day, not near Brandon, but between Brandon and the border there was. Our experience of the storm was still significant rainfall. It kind of dumped its guts. It went through its cycle, basically right over Brandon. Before it did, but on its way into town, it put on a lightning show that was just... And when I say it dumped its guts, I mean flash flooding. So, the altocumulus lenticular. It's a lens or almond-shaped cloud, generally on the lee side of mountain ranges. Indicator of strong, high-level winds, no precipitation. I often see this as what might be considered an area of stability in that area of the atmosphere as well.
Oh yeah, and that's usually comes here. These types of clouds are pretty typical, especially in Alberta, on this side of the Rocky Mountains, where we have textbook Chinook conditions. So you get these types of clouds developing with the Chinooks or right behind the Chinook arches or anything like that. And they could actually come along the Chinook arch as well. But definitely indicator for those stronger high level winds and turbulence, especially if you're flying into these types of clouds or anything like that, you're definitely going to run into some big time turbulence up in the upper atmosphere at least. So they can definitely indicate the wind potential in a winter's day or even in the summer's day as well.
So the layer in which they inhibit may be somewhat stable, but the air above most likely definitely not.
Yeah.
Next, let's talk about the nimbostratus. It's a dark gray cloud. It covers the entire sky and blocks out the sun. There's stable air there. It's a warm frontal cloud with continuous rain, which may be light, moderate, or heavy in intensity, depending on, I guess, which part of the larger overall system you're getting. Thunderstorms are sometimes embedded if air mass is unstable. And so what that means is you may have a large area covering a large geographic area of
rain,
the system moving through, and it's kind of rainy throughout there, but you may have
the
individual thunder and lightning cells that pop up with inside.
Usually typical. The odd little rumble of thunder, nothing crazier or anything, nothing severe or anything like that. But you definitely get the odd. And I believe that would be also the case with the thunder snow events that we get in the winter months as well. You get a very heavy pocket of snow, and if you get enough of that instability in that heavier pocket of snow, then you'll end up with the thunder snow potential.
People think thunder snow is a really rare thing, but it's not if you're at the right elevation, right?
Oh yeah.
If you're up at the top of the cloud, that's pretty common.
It is. Yeah, it is. And now that we have the technology now, because like 10, 20 years ago, we didn't have the technology to find thunder snow all the time. So now you see it almost every big snow event, especially in the eastern half of the country, where they're really typical for getting some good thunder snow. But now we're starting to see a lot more here in the west as well.
Certainly have a friend somewhere in northern Ontario, closer to the Ottawa Valley side, who posted today, that was the loudest crack of thunder I've ever heard. And knowing how many thunderstorms they've probably experienced.
Those storms were moving fast today. They're like booking it across the Great Lakes.
I wonder if that was a positive lightning strike that was near their house.
Likely. Very likely.
Therefore, because I'm sure my friend is, who I knew from Hamilton, Ontario, where there's lots of lightning storms all the time, is familiar with having close lightning strikes. So that's what made me think, maybe was that a positive? Okay, let's talk about low clouds, seeing as we're talking about lightning, because we're going to be getting into the real deal here. Bases of these clouds, they're generally from the surface up to 6,500 feet. They consist of water droplets or supercool water droplets, ice crystals in the towering clouds. During the summer months, cumulus cloud bases may range as high as 4,500 meters to 15,000 feet, or even higher. Cumulus clouds are often referred to as clouds of vertical development. They stack up. So first we'll talk about the stratofractus. I mean, I don't remember all these names like stratofractus. When I'm sitting out there watching weather and someone's like, "Oh, what's going on there?" I'm not like, "Oh, that's stratofractus." But I might say it looks like it's pretty stable air there. There's fragmented and wispy clouds. They form in precipitation.
Oh yeah, yeah. I see that a lot, especially on the backside of backside of storm systems, etc. Like the big monster low pressure systems, mid latitude cyclones that track across the prairies. You see that type of cloud right in the backside there, especially when you're getting a whole bunch of rain or snow or anything like that. So that's quite typical there.
So stratofractus is stable, but unstable is cumulofractus. These are fragmented, wispy clouds that form in precipitation, unstable air. There's not a very good definition there.
Yeah, that's the same thing. That's more so on the backside of thunderstorms, or kind of in thunderstorms. There, you get these little, once in a while you're watching a storm and you see these random little small clouds float by, something like that. Yeah. Those are the types of clouds that you see on that. Oh,
yeah, it gives us sort of example too in the image of there's a rainbow and you can see the storm sort of in the distance, and it's sunny over the houses in the foreground, and that kind of gives you the impression that the storm has just passed. Stratus clouds. These are the real low ones. They're a uniform layer of cloud. It's a stable air mass. It may produce drizzle, but not really with appreciable accumulation. It's just kind of like a bland, crappy
day.
Yeah.
Yeah, that's what you get from stratus clouds. Yeah. No exciting weather comes from stratus clouds.
And very closely related would be fog. And this is
that's what I'm seeing out my window right now. It's just fog. Can't even see the neighbors right now. It's been like that most of the day.
Well, it's double digits down in Lethbridge, but up where you are in Brooks, it's what?
It's like 4. We got to 4 today.
And not far from you, how far do you have to go to hit the freezing mark right now?
Well, south of us, we only have to go. Like, it's pretty incredible here how the weather plays out here in southern Alberta. So you can have like double digits, Lethbridge, Medicine Hat, and then we are stuck in this fog. So we're 3 degrees here. So we've jumped up above. So you get to the south, like Rolling Hills, it's 7 degrees, 8 degrees. In Enchanton, these 2 places is about half an hour away. So it's pretty incredible. And then Bazzano is like -1 right now. So they've been below freezing all day, and they've been in the fog all day long in Bazzano at -1 degree. And then you go south of there about half an hour and it's 8 degrees. It's pretty incredible.
Fog can also occur during inversions, especially in the morning.
Brooks. Typical inversions. You get that cold air trapped at the surface, has nowhere to go. It's not moving anywhere. And then you get that wind. You don't get the wind or anything like that. So it has nowhere to go because cold air sinks, hot air rises, that type of ordeal there. And then that's the typical inversion that you see here and across the Brooks area, while everybody in Lethbridge are in the wind gusts of 60 kilometers an hour, hair blowing all over the place, and 11 degrees outside. Typical Alberta in the wintertime.
Stratocumulus clouds. These are bands, sheets, or patches of cloud with a rounded shaped appearance. They may be frontal, pre or post frontal, or associated with an upper trough. They may produce light rain or light drizzle. So not a cloud that's incredibly indicative, I guess.
No, not really. Yeah, definitely kind of in the it's kind of more so in the stratus group, but there will be cumulus clouds, and these are also kind of those dismal days that you get in any time of the year. You get a stratocumulus deck right over top of you, and it's not going to be the pleasant of pleasant days, but sometimes it's not too shabby outside, as long as there's not a wind to go along with the rain, light rain, drizzle, and light snow, because this stuff can also produce that light snow in the wintertime. Stratocumulus clouds.
I would hazard to say that's what I'm observing outside my window right now, is basically a stratocumulus sort of deck sitting on us.
So yeah, that's pretty much you get the stratocumulus, I get the stratus on top of me.
So here's where we start getting into the fun ones. These are the ones that make us love clouds.
Oh yeah.
The rest is just all leading up to, are these things going to happen? Yeah, right. So the cumulus cloud, it's a puffy white cloud with a flat base. It's flat because it's rising. It's got unstable air. Usually fair weather is going on at the time, but if observed during the morning hours, it may start to grow to towering cumulus or even cumulonimbus during the afternoon in the summer months. No precipitation comes out of the cumulus itself, but it can be the building blocks for something bigger.
Oh yes, absolutely. Especially whenever there's a day with full-time instability. So you have the let's as we go back to our other clouds like the alto cumulus, the those alto cumulus focus clouds we were talking about earlier. These clouds, you start seeing these types of cumulus clouds start to pop up through the day, and that's the indication that the players are out in the field and they're ready to play. So that's how you know it's going to be a good storm day when the players get out in the field.
That's true, especially if the players start playing, and that's what happens when you start getting some towering cumulus. TCU.
Oh, yes.
Tall
TCU.
cumulus clouds, which may be growing, well-rounded, cauliflower-like tops with flat bases. Things are rising. There's no precipitation really coming out of it. Yet, there's unstable air going on there. The ground's heating up and the air is rising. May be frontal, pre or post-frontal, with an upper trough or general air mass. Light, occasionally moderate showers are possible in Virga. Downdrafts with erratic gusty winds may come as the air goes up. It sometimes comes down. It cools and may fall. May grow into cumulonimbus, and that's what we're really interested in talking about, is when you start seeing the clouds stacking up and you're watching their development and that process, they keep getting bigger and bigger and bigger. If they start going past that towering cumulus stage, then you know you got some problems coming on.
Oh yes, absolutely. Yeah, when they go past that towering cumulus clouds, you start seeing that base start to get dark at the bottom of the so-called towering cumulus cloud, and that's an indication that a storm is a brewing. And as you see as we saw in the write up there, that it will likely produce downdrafts with those gusty, erratic winds. Even if it's not a thunderstorm yet, it could still produce those fairly strong, gusty winds that could, at times, possibly be damaging if it is strong enough of a wind that blows out of these cells. And that's also indication that we have a developing storm that is in the area. And typically before, how also know another way to find out how a storm's really starting to develop here as we look into the cumulonimbus clouds ahead of us is the, as I mentioned, the easterly wind. If the wind is blowing into the storm is rapidly developing and it will likely intensify before it settles down. And usually when the wind's blowing out of the storm, that's usually an indication that the storm is dying off, but it's still a fairly potent storm depending on how strong it has gotten up to its stage and pretty much how fast the storm is moving too. So,
well, and these things can cycle as well, right? So I think of it like a living creature. It like breathes in, it breathes out, it breathes in, it breathes out.
yeah.
In the timing of that, breathing in and out, sometimes on your fire can be really detrimental. Now, one thing that happened with us this year is we were facing burn off. The burn off had begun, but then thunderstorms started developing in the afternoon. What the thunderstorms were doing were steady inflows. They were sucking wind, and we'd already got that burn half going. And I was acting as weather guy. I said, keep sending it because it's going to come and blow out eventually. It's going to exhale. It's going to outflow eventually.
Yep.
And it's going to push fire over the guard probably at that time. Well, if we burn enough up in the meantime while it's sucking wind in, maybe we can burn enough of that fuel off that there's not much. And so that's exactly what happened was the storm sucked in, pulled the fire towards it, and burnt off that whole section next to the guard. And then when it breathed out also accompanied with extremely heavy rainfall in the core of the storm. That we took a direct strike from that storm, and we won the battle. The fire held, the back burn was successful. Things you want to look for as well with that cumulus development is when it starts getting a bit of a anvil on top, right? It's starting to grow, it's starting to reach out, and it's kind of hitting the top of where, it's able to kind of grow, so it's starting to stretch out. These huge cumulus clouds with flat base, and they have an anvil top.
Anvils.
The top may be in the form of towering cumulus, but the edges become fibrous. There's very unstable air going on here. This forms along cold fronts, in squall lines preceding a cold front, embedded in warm frontal cloud if the air mass is unstable with an upper trough, or general air mass thunderstorms when enough heating and moisture is available. Showers of light, moderate, heavy, or very heavy intensity are possible. Virga, hail, lightning, and tornadoes are possible. Downdrafts will produce strong gusty winds from 50 to 90 kilometers an hour. Microbursts can produce winds as high as 150. These clouds may develop like individual cells, clumps of cells, or even in a full line of thunderstorm cells, like we've seen at times when a line of storms comes across BC and lights up fires all over the place. And then, people don't need to take thunderstorms seriously. First of all, like one lightning strike can kill anybody who's on the hose line if it hits near the hose line.
Oh yeah, that's
you
right.
Have groups of people on the hose.
Oh, I bet.
So
yeah.
It's very important to start noticing when these cumulus clouds turn over and start turning into that thunderstorm. And people will ask me all the time, do we have time? And I'm like, we still got time. We still got time. And then there's like this moment where I'm like, cancel what I said 5 minutes ago. Time's up.
Yeah, because there's sometimes the storms can move very slowly, or sometimes they can move very, very fast. And I've seen storms book it at 90 kilometers an hour across the prairies, BC as well. I've seen that occur as well. Like when you get a very sharp cold front and you see these storms start racing down the interior sections there, and it can turn ugly very fast. And I remember, I think, it was the one time we were on Kootenay Lake there. And this was like, this was like 2007, 2008, before we had really good technology. And I could tell the storm was going to be, I was really getting into my weather forecasting game here. And I could tell this day was going to be a rough day in the Kootenays. And of course, nobody believed me, So we get to like Joe. It's the boat place called Jones Boys there on Kootenay Lake, and you can see the storm coming in fast. The lightning strikes. You can see them coming in closer and closer and closer. I'm like, we should stay here and wait this thing out. But nope, we all ended up getting on the boats, and we ended up driving through the storm in 90K winds on boats. And that was probably one of the wildest rides of my life on that lake, because when that lake gets going, it gets going there. So that was that was my thing with the thunderstorm bat. And we should have listened to Brandon there. Yeah,
it's a big wind tunnel there too, and you have all that convection that starts happening right up in the mountains between there and Salmo. The Creston Pass. Yeah, a great place for thunderstorm development. So this is an example for sure. I've been in Sirdar on Kootenay Lake and watched thunderstorms just light the whole mountain range across the way up. It was absolutely fantastic, colorful, beautiful sunset show. Really fantastic memory for sure. So you could have these outflow gusts in the front of the thunderstorm can knock down trees. It can stoke erratic fire behavior. So these are things like you need to take seriously if you're a crew leader and get your crew out of the woods before that storm turns over, right? When you start hearing that thunder, get moving. That's really the point, and I'll call it on the radio. Even sometimes with my crews, like 100 meters away, I'll be like, okay, guys, time to pack it up, blah, blah, blah. I could probably yell to them and they'd hear me, but I want everyone on the fire to hear Joey's pulling out. And then you start hearing other crews one by one going, okay, maybe we should do that too. So, and when we talk about some of these damaging wind events that can come out of a thunderstorm, I mean, these things do happen in British Columbia. Maybe we don't get F4 tornadoes that remove entire towns. No, okay, that doesn't happen much in BC for sure. But tornadoes are possible, but even more likely are the frontal winds of the storm being very damaging, or microbursts, just extreme downdrafts sometime we're in the middle or back of the storm.
Just get well clear of this hose lay. Just get well clear of the hose lay.
Oh yeah, and I've also seen some storms produce some hail there because when you get hail out of these, because it's taller the clouds, you also get the hail because hail forms with the raindrop. Snowflake falls, makes the raindrop, and then it gets into the updraft, and it circles around as many times until it gets too heavy, and then it falls from the upper atmosphere there. So that's how you get the hailstones there. So we're more likely to get that here in Alberta with their orographic lift there off the foothills. But I've seen hailstorms happen in the BC interior, and hail, it hurts when it hits you.
We sometimes get some significant hail, especially in the Cariboo, Prince George regions, which is the most active thunderstorm region in the British Columbia interior. We talked about Virga a fair bit. One thing we didn't mention is it's also indicative of dry air below the clouds. The rain's trying to fall and it's not able to, right? So that can, for your location, the fire, give you some indication if you don't have, say, your Kestrel, your sling psychrometer out telling you what the humidityx values are at that moment. Tornado, we can talk about real quickly, because they do happen, especially out, say, if you're somewhere south of Vanderhoof, out in the Cariboo Plateau, you're somewhere in the woods outside Prince George, you may have a short-lived tornado event happen. A violently rotating column of air, everyone knows what a tornado is. It's from the base of the cumulonimbus cloud. It touches the ground. If it doesn't touch the ground, it's not a tornado, it's just a funnel cloud. This column is extremely powerful. Wind speeds can be 116 kilometers to over 420. Updraft wind speeds can reach 300 kilometers an hour. It's extremely unstable air, evidently extremely unstable air. Tornadoes do happen in BC. They do.
Yep, they can happen. Yep. That was off the coast near Vancouver last year, wasn't it? Last November had a tornado, or was that the year before? I think might have been the year before.
Well, we had a couple confirmed funnel clouds this year in BC. That's a violently rotating column of air that's coming down from the cumulonimbus. It's not in contact with the Earth, though. That's the difference between a funnel cloud and a tornado. The tornado touches the ground, the funnel cloud does not. This can be extremely powerful updraft into the cloud. It could become a tornado. That is possible. We've seen the one that happened down in Princeton, BC this spring. I don't believe it became a tornado, but it was definitely quite photogenic for a short period of time.
Oh, yeah. Yeah, and Alberta is also pretty well known for our tornadoes this year. That's for sure. With over, how many did we have this year? About 60. Yeah, about 16 tornadoes this year. So, meanwhile, Saskatchewan only had one tornado.
Yeah.
Yeah. So, yeah, tornadoes can happen. That's for sure.
They certainly are more your thing than they are our thing here. And I think people in BC know that, and so they don't take thunderstorms seriously enough. That's the problem with the lazy attitude that people have towards thunderstorms, is they've seen a few thunderstorms in their years in BC that kind of rumbled and did something, this or that. They don't really take seriously, like, hey, when I said today's a severe thunderstorm day, I absolutely meant it. Like you're talking about storms coming in at 50 kilometers an hour, like when we were in Fraser Lake on top of the mountain this summer. And not only can they move extremely fast, but they can develop extremely fast as they're crossing different terrain, different zones of climate in BC, right? So those storms developed out of the blue and just slammed in so fast that I barely got to the truck in time. But got back to the truck in time, I did. I talked about a microburst already. It's a very intense downdraft out of the cumulonimbus clouds. It spreads out in all directions. That's how you can often tell the difference in damage when you come across like a blowdown area in the forest and you're like, what happened here? Well, all the trees are going one way. Well, you definitely had a plow wind or a frontal wind, all the trees were laid out kind of like they were just flattened. Well, that was a microburst. Well, the trees were all twisted and ripped and thrown different directions. Well, that was definitely tornado damage. So you can tell just by the kind of damage you're seeing in the forest what happened there already.
Oh, yeah. Yeah. I got caught in a couple microbursts in my lifetime before. Yeah. I think, it was 2019 when we had, I was thinking there's going to be 90 to 100K winds. Okay, cool. But it was way stronger than that. It was at least, I'd say, how strong was that? Oh, at least 130, 140 wind that came howling through there. And everything lifted up in the air and went flying. And there's this boat. We had this kind of dinghy thing, and it flew across the yard. And we had this gas. There's no gas in it, but it was a big gas tank, and it hit that tank, and it went bing, and it put a hole in the whole dinghy. So the dinghy was no longer usable after that day. And then it took the apple tree. Part of it, I was lucky. I was behind the tree, so the apple tree went flying this way, and it took the hot tub cover off and threw it against the house. So it was an intense day back in 2019.
That's violent. Well, imagine you're in the middle of the forest and that starts happening.
Oh yeah,
Man.
that wouldn't be good.
Yeah, you got trees coming down, sticks, things flying. I mean,
Yeah,
terrifying, right? And that's kind of the bigger point I'm trying to get to as well when we're thinking about the fire environment is like, man, a thunderstorm can do a lot of different things. And it doesn't have to be an extremely aggressive thunderstorm to do something particularly violent where you are.
Yep.
Because it could just be one moment in one place in time where it goes.
yeah,
Lightning. That's a thing that can go and ruin your day. It can be cloud to cloud. It could be inside the cloud. And it can be cloud to ground. So that's, the basic two kinds of lightning. There's not really anything else that we're talking about, especially. I mean, we're not talking about sprites in the sky today. That's not relevant to fire talk. We're not talking about ball lightning. We're really talking about the two kinds of lightning that thunderstorms produce, cloud to cloud and cloud to ground. We're interested in cloud to ground because it's a static of discharge, discharge of static electricity from the cloud to the ground. It can be positive, it can be negative. Negative is from near the base of the cloud, and positive is from the top of the cloud. Although both types of lightning start fires, positive strikes are considered to be more dangerous due to the longer duration of the stroke. It's more likely to strike outside of the rain area. And dry lightning occurs when there's little or no precipitation from the cloud or strikes outside the precipitation area. There was a time during this crazy blow up of fires this summer in BC in August where I was watching the lightning indicator and there was some fresh strikes that happened way north of Clearwater. And I said, there's storms going on there. I checked radar scope and no, there wasn't. The nearest thunderstorm was 70 kilometers away, Brandon.
Oh, wow. Would have that been dry lightning?
It would have, it reached way out.
Oh yeah. It can. It's like what was this one storm I saw in the US, this lightning strike, reached at least 100 kilometers away from the whole thunderstorm itself. So that was it was like a couple of years ago, but it was very impressive. And you can see
That's why we tell people if you can hear it, you're too close.
Oh yeah. Hear the thunder? Yeah, you're too close. Yeah.
So
Thunder roars.
if you can hear it, it can reach you. Well, it could reach, a lot further than that. You were already potentially at risk before you could hear it. And during the daytime, you're not going to hear it for very far, 10 or 15 kilometers, depending where you are,
Yeah.
Maybe out in the open prairie, you might hear it a little further. I don't know.
Yeah, usually you'd hear it. Sometimes, you can hear it if there's not a lot of wind ahead of it. If you have a lot of wind ahead of it, then you can't hear it. But if sometimes I can hear, like there's a storm going on like at Lomond over here, which is about, let's say half an hour away. So kind of like the same ordeal with our temperatures that we're dealing with right now. So there's a storm over there at Lomond and you could hear the thunder. It's not very loud. It's like a boom, boom. You're going to, oh, was that thunder or just a thump, a little thumping noise off in the distance there. And sometimes you can hear it from that far away and you can see the anvil way over there too. So it's pretty cool sometimes.
Yeah, out in the open prairie, you have that chance. In the BC mountains, especially, and and just the wavy topography wherever you are, you're probably not very often getting a chance to actually make visual contact with something that far away, especially if you're in the trees, right?
Oh yeah.
Mammatus clouds. These mammatus, mamma being the root word, right? These booby-shaped clouds, these rounded globular masses hanging from the base of the cumulonimbus cloud. Their mechanism for formation is not well understood. Generally occur during the dissipating stage and is a sign of cool, moist air sinking out of the cloud with dry very dry air beneath it, very unstable air. But generally, when I see the Mammatus cloud, I figure the show is over.
Yeah, usually, yeah, it's usually typically at the end of the backside of thunderstorms. Usually, it's where we find those, and sometimes other occurrences as well. I've seen Mammatus clouds when there wasn't a thunderstorm around. So it's like in a day where we've had, but that's also known that we've also had some unstable air in the atmosphere. And those types of clouds, if for anybody who's flying around or anything like that, I would not want to fly into any of those kind of clouds because there's a lot of turbulence up there. You're going to go for a ride if you fly into one of those clouds.
There you go. If you have to do some heli bumps and you're seeing that overhead,
Mhm.
maybe wait that out for a few minutes before you start doing crew moves.
Yeah.
Hail. It's ice pellets that fall from the cumulonimbus. So strong updrafts have been going on in the cloud. It's been carrying moisture, little tiny bits of ice crystals that got
Ice
bigger
around, and
and
it grows and grows and grows and grows. And then if it decides, okay, we've had enough of this, we're going to drop it, and it drops it down to the surface as any type of hailstone. So we go from pea size, and here in the prairies, we're pretty known for our tennis ball size, baseball size, and softball size hail. Especially off the foothills, we're also known for Hail Alley on this side of the Rockies. And then, as you said, yes, BC can also get that hail through the interior sections. Probably not as big as Alberta's hail, but still can do damage if it's big enough. Oh yes.
if you get a real severe storm, ping pongs can happen in BC for sure.
Mm-hmm.
I've seen that kind of thing a couple times for sure. Marbles, more likely. So something that's bigger than dime size, maybe even
so
quarter
like
size.
toonie size, right?
Yeah,
Toonie size hail. So we go
That's-
with that.
that can be possibly a large marble. So anything in that kind of size, pretty common for British Columbia. But yeah, in Alberta too, you've seen when you get those like coalescing balls of hail that follow the sky. It's like there's a rock.
Size of this.
There's that rock type, that conglomerate. It's a concretion. It's like 10 rocks within one rock. And you'll see a hailstorm that sometimes forms like that, of like many big hailstones coming together.
Mhm.
And what's going on too is like you must have winds pushing 200 kilometers an hour straight up.
Get a lot of wind
to
aloft too, so that pushes the hail around. So it's like bouncing around up there, bouncing off each other. Yeah, and if it freezes, and sometimes you get the hailstones kind of stuck together too. So lots of stuff is happening up in the upper atmosphere.
To get that grapefruit size, you need some
Oh, yeah.
big time updraft wind going on. And as that's bouncing around up there, it's creating static electricity. And it's probably going to create some lightning, right?
Oh yeah, absolutely.
Pyrocumulus. This is a good one for fires because sometimes I've seen fires try to make their own thunderstorms. A couple times I've seen it successfully happening. I've seen it
Oh, yeah.
in person on a couple occasions now. That's where cumulus clouds are forming over a large fire. And they may be starting to grow into a cumulonimbus cloud and produce lightning. All the stuff that's burning, it's releasing lots of gases and moisture. Lots of moisture is going into a cloud, right? So a fire cloud, right? So you're looking at this fire cloud lifting up, and then it's starting to like look more and more like an actual cloud. And so it's a pyrocumulus cloud at this point, but then it becomes a pyrocumulonimbus cloud if it starts getting that towering amvor, it starts having that classic thunderstorm shape, and it comes right out of the fire. And then at which point it may leave the fire and take off and do whatever damage it wants wherever it wants to go. And that's what we saw in 2021 at our fire at Cutoff Creek. The fire fed the storm all afternoon. I've seen fires feed storms too that weren't necessarily pyrocumulus storms.
Yep.
I have seen the storm sucking it and the column going straight in and visibly interacting and making the storm angrier. So, I mean, these can be interactions that are worth noting on a thunderstorm day, especially if you have really active burning going on. And so, yeah, it let go at Cutoff Creek, and then it went up towards Fraser Lake, and lightning just came out of the thing like crazy. It was awesome. Terrifying.
Oh yeah. Yeah, and the same thing happened in 2016 Fort McMurray fire too. That one definitely produced its own weather as that burned for weeks and upon weeks there in northern Alberta, and it produced that pyrocumulus cloud right over the area and produced quite a few lightning strikes, multiple multiple days of lightning strikes out of that thing. So it produced a lot more fires. Yeah, it was wild.
Well, in 2021, during the heat dome, the big fire outbreak, that's what
Oh, yeah.
happened as well, right?
Yeah, that-
We were
that's
watching
alien.
and reporting on it as it happened. The columns of smoke were creating thunderstorms, and then we're taking off and doing all kinds of damage. They were severe storms. They were quite wild, and they lit a lot of fires.
Yeah.
Okay, we got to keep moving on because we are getting on. Dust Devils seen some big ones out on the Caribou Plateau this year, and fire whirls. I've seen these before as well. Fire whirls can become fire tornadoes. Indicators of intense local heating and very unstable air. Updrafts of 40 to 60 kilometers an hour can develop at the whirlwind speeds up to 40 to 90 kilometers an hour. Yeah, the fire whirls, man, they can happen for sure. You don't necessarily have to see a huge firestorm for a fire whirl to be occurring. It just has to be, the heat has to be intense enough, I guess, at the location of where that begins, right? But that can turn into a fire tornado and kind of do whatever it wants.
Oh yeah, if there's enough vortice in there to make it spin, it will do it.
Definitely saw fire tornado in BC this year, somewhere down by Lillooet, I believe.
Okay, yeah.
I didn't see it, but it was all over the social media. And I believe our last one to talk about today is the inversion. Inversion's really important for fires. I mean, this is a really important one. There's warm air, as Brandon was saying, it's over top of the cold air. It traps the smoke and pollutants below. Nocturnal inversion forms due to radiation cooling under the clear or mostly clear skies and calmer light winds. Often in the mountains, you'll find late in the day, the inversion can happen too because the warmth has been rising up all afternoon, and then as the sun angles sort of change in the valleys cool off quickly. And so I'll be down here in Wells, and then I go up to the mountaintop, and I'll be like, wow, it was so cold in the valley, but it's really warm up here. Now this can have lots of interactions with fire, evidently, right? Can also create lots of fog in the morning, keep things really cool down there in the bottom, trap everything, that making helicopter flights impossible to come in and land or take off, but also keeping very humid air down at the bottom, and therefore keeping your fire activity kind of low.
Yeah, that's right. And once again, that inversion keeps that colder air right down to the surface, the cooler air. And it's not just for fires, but also during the winter months as well. Keeps the pollutants at the surface. And same thing with the smoke, keeps it down to the surface. And that's why you have pretty much multiple days upon days upon days of very smoky conditions in some locations, especially during the fire season in BC, Alberta, all across Western Canada there.
Well, I think we're done talking about clouds that relate to fire weather today, and just life in general. You know, when you see these clouds, what do they mean? So I hope that kind of helps you get a better idea. Thanks, Brandon, for talking. I always love talking to you. And I guess we'll see you for Thursday night at the Meteorological Report right here on this channel.
That's right.
Yeah, we had a good episode this week.
Yes.
Yes, we did. Hey, thanks for coming on by. Hit subscribe, and if you want to find Brandon, you can find him on Twitter.
Or X, whatever you call it.
Oh yeah, it's got a new name now.
Or Facebook or TikTok or Instagram, you know. I'm all over the place.
There you go. Okay, we'll talk to you soon, buddy.
Talk to you soon.